Hey, this is Mr. A, and this is the second video in Unit 6, and it is left and right-handed Riemann sums. And you're like, what in the world is a Riemann sum? Well, a left-handed Riemann sum is one that needs those special kind of scissors that can only cut paper for left-handed people. Nope. Left-handed Riemann sums is this. It's kind of like a summation. If you remember our last video with our integral sign, that little crazy integral sign that looked like this, and we're going from 0 to 4 of some sort of function of f of x with dx, and we're taking the integral. What did this crazy little integral sign means? Well, that is the sign for summation, for adding up. And that'll make sense when we do what's called a left-handed Riemann sum. We're going to try to find the area under this curve from 0 to 4, which means we want to know the area all the way from 0, x is equal to 0, all the way to x is equal to 4. And we're trying to find our area, and we're going to do what's called a Riemann sum, a left-handed Riemann sum. So what a left-handed Riemann sum is we start at our f of 0 right here, at f of 0, which is 1. And we're going to do a rectangle. And here, then we have f of 1. And we're going to do a rectangle. And then we're going to do f of 2. And we're going to do another rectangle right here. Okay, if I can do it really well. And here we have f of 3. We're going to do a rectangle right here. Okay, and guess what we're going to do with the area of all these rectangles? We're going to sum them up, baby. We're going to add them up. Now you can see they gave us this function, so we know where we have each one of these y values. At f of 0, you can see you plug 0 in our function. F of 0 equals 1. Okay. F of 1 is 1/2 of 1 squared plus 1. That's 3/2, or 1.5. And here, f of 2, 2 squared times 1/2 plus 1, that equals 3. And f of 3, 3 squared is 9, 9/2, 9/2 plus 1 is 5.5. And so we're going to add up this area, and that is called a left-handed Riemann sum. So you can see how here we start with, we're going to do base times height. Our base is 1. Our height is 1 high. Plus our base is 1, plus our height times our height of 1.5, plus a base of 1 times a height of 3, plus 1 times a height of 5.5. And so what do we have? We have 1 plus 1.5, that's 2.5, plus 3, that's 5.5, plus 5.5, which equals 11. The area under this curve is 11. Now, is the true area under this curve 11? No way, because guess what? We're missing a bunch of area, aren't we? We're missing, and I'll do this in a different color, in blue. We're missing this area here. We're missing this area here. We're missing this area here. We're missing this area here, which means this is an underestimation, isn't it? So the left-handed Riemann sum, when the function is increasing, we know that's always going to be an underestimation, isn't it? And so we call that a left-handed Riemann sum because we're starting with left-handed points to find that. Now, what about a right-handed Riemann sum? Yeah, baby, you and I would add up better than a Riemann sum. So what if we were doing a right-handed Riemann sum? Well, the right-handed Riemann sum means we start on the right side. We start at 4 at f of 4, which is all the way up at 9. And we're doing a rectangle. Okay, if I can do this rectangle like that. Then we go to 3, where 3 coincides. We're going to do his rectangle. We're going to go to 2. We're going to do his rectangle. And we're going to do at 1. Okay, so what do we have here? We're starting up here at 9. So we have 9 times a base of 1 plus 5.5 times a base of 1 plus 3 times a base of 1 plus 1.5 times the base of 1. And so we have 9 plus 5.5 plus 3 plus 1.5. So 3 and 1.5 is 4.5. 4.5 and 5.5 is 10. Plus 9 is 19. So the area of this is 19. Now C, you can see how this is an overestimation. an overestimation, which means a right-handed Riemann sum for an increasing function will always be an overestimation, because you can see I'm adding this area and this area and this area and this area to my right-handed Riemann sum. Which means, think about it, if the left-handed Riemann sum was 11 and the right-handed Riemann sum was 19, and the left-handed Riemann sum was an underestimation, and the right-handed Riemann sum is an overestimation, that means the true area, the integral of this function with respect to x, has to be somewhere in between 11 and 19. It's not going to be exactly in between. It's just going to be somewhere in between. It depends upon the function. Now, something I want to say, when I was doing the left-handed Riemann sums, you might have said, Mr. Aiden, why didn't you take this and do this rectangle, and then this and do this rectangle with a base of 2? So here we have 1 high times a base of 2 plus 3 high times a base of 2. That would equal 2 and 6, which is 8. Well, that's an even worse estimation, isn't it? But I only used 2 equal intervals there. 2 equal intervals. When I did it from 0 to 4, I actually used 4 equal intervals. Could I have used more? Heck yeah. I could have done half intervals. Okay? I could have done half intervals. That would have made even better of an estimation. Better of an approximation. Okay? If I continue to use half intervals. So you can see how that would double the amount of intervals. I would go from 4 intervals to 8 intervals, and guess what? That would even be an even better estimation. And so what is the integral of my function with respect to x? That is an infinite number of Riemann sums. It's an infinite number of rectangles. An infinite amount of rectangles. So, let's do a problem. Here, we're going to use a right Riemann sum with 3 equal subdivisions. 3 equal subdivisions. So, you can see I'm going from -2 all the way to 4. Which, how would I do 3 equal subdivisions? Well, those 3 equal subdivisions would be 2 units in length, wouldn't they? Okay, so if I'm doing a right Riemann sum, I'm going to start where it coincides the right hand place. And this is the rectangle I'm doing. Then the next one is the next point where my graph interfaces. That was an awful, awful line right there. Let's try that again. That was even worse. Then right here. Now, this function is increasing and then decreasing. So you can see, I don't know whether I'm going to be an overestimation or underestimation. I really don't. So I got to take a look at my areas. My area of this rectangle is 2 units is my base. My height is 4. So 2 times 4 is 8. This one is 6 units high, 2 units in length. So that's 12. This one's 4 units high, and 4 times 2 is 8. Now, these are all above the x-axis, which means they're all going to be positive. Positive, positive, and positive. If they were below, it would be negative. So I add all this up, and I end up getting 28 is the area. I don't know whether that's an overestimation or underestimation. You can see I have a bunch of extra area there, some extra area there, and it's a little bit under area there, and then I missed this area, right? Oh wait, we're not going there. And then so it's probably a little bit of overestimation, but I can't quite know for sure. Now, what happens if we have a table of data? Well, you could kind of graph out a table data, or you can use your left-handed Riemann sums. So your height on the left side starts at 5. What's the difference? The base is going to be 2. Then we go to the next point. The height is 1. The difference is 2. Then the next point is 7. That's the height. The difference is 2. So I'm going from the left-hand side. So 10 plus 2 is 12, plus 14. 10 plus 2 plus 14 equals 24, 26, 26. There you go. So that was using the left-handed Riemann sums. Let's try to do this problem, but with the right-handed Riemann sums. So we're going to do both here. So let's do the right-handed Riemann sums. So that means we start with the right-hand side first. We start with 7 is my height, and I'm going 2 this way. Then I go to 7. I'm doing 2. My base is 2. Then I go to 1, and my base is 2. So this one is 14 plus 14 plus 2. So that's 28, 29, 30. So you can see my function was decreasing and increasing and stays constant. So I don't know whether these are, obviously the left-handed Riemann sum is probably going to be an underestimation. The right-handed is going to be a little bit of an overestimation. And the true one's going to be somewhere in between. Okay, so here we want to do a right-handed Riemann sum with 3 equal subdivisions, and I'm going from 0 to 1.5, which means I want to go from x of 0 to 0.5, then to 1, then to 1.5. You can see there's 3 equal subdivisions, and then you can see we're using h of x. So we're going to plug in h of 0. H of 0 is going to be undefined, isn't it? Undefined. Because 3 over 0. Then we're doing h over 1/2. So h of 1/2. 3 over 1/2. So 3 divided by 1/2 is like multiplying by the reciprocal. So 6. Then we're going 3 divided by 1 is 3, h of 1. Then we're doing h of 1.5. So 3 divided by 3/2. So we're going to do the reciprocal, which ends up giving us 2. Okay. Now, if we were to do the left-handed Riemann sum, well, that's really tough because we would start with an undefined function. We don't want to do that. So we're going to do a right-handed Riemann sum just like they asked us. So the height is 2. The base is 1/2, isn't it? 0.5. The next height is 3. The difference is 1/2. The next height is 6. The next difference is the base is 1/2. So we have 1 plus 3/2 plus 3. So 1 and 1.5 plus 3. So 4 and 1.5. 4 and 1.5 is 5.5. And that would be the area, the approximation of the area of this axis. So when they give you a function, you can plug numbers in to find out your y values. And then you can do your Riemann's sums. Okay? Here's one last one. We want to know the Riemann sums. We're going to order our areas from least to greatest. From least to greatest. Now, you can see our function is decreasing. It's constantly decreasing all the way from -7 all the way to 7. Which means when I do a right-handed Riemann sum, think about a right-handed Riemann sum, that's going to be an overestimation. So the right-hand Riemann sum is going to be the overestimation. The left-handed Riemann sum, which starts over here, is going to be a Riemann sum kind of looking like this. That is going to be an underestimation. And the actual is going to be right in between. Which, think about that. The left-handed Riemann sum is going to be the least, and then the actual, then the overestimation. Okay? So what did we say is when our function is increasing, the left-handed Riemann sum is always going to be an underestimation. If it's decreasing, it's going to be an overestimation. And remember, guys, don't underestimate me and don't overestimate me. Just estimate me next time. Okay? Got that? Estimate me. Just do it. Estimate. Have a good day.